Thank you so much for joining me today.
Thanks for having me.
Let's start with your view on open source AI. And across podcasts and writings, you mentioned how the open approach, it'll have a hard time beating the closed approach from like large companies. So can you just start with what's going right with open source AI, and also what are the challenges that they might face?
Yeah, what's going right? A lot is going right. I'm very excited to see this community popping up, not falling too far behind the frontier models. But yeah, like you said, there will always be a gap, I think, between what's really state of the art, simply because it requires a lot of resources. But I think one of the trends that gives me a lot of hope is Meta's Llama models, where a lot of folks can do very interesting things on top of it, because Meta is essentially repeating the same recipe as what they did with PyTorch, right? So PyTorch was this framework that enabled basically this revolution, right? So like OpenAI probably wouldn't be as good as they are without PyTorch. And it seems like they're doing something similar now with Llama, which is going to be the PyTorch of language models. And that's going to unlock a lot of, really exciting things.
Right. So, and also obviously, what's hot off the press is the executive order on AI. The White House published what they want to do, what they want to achieve, and so in that, just to start off, like, what's your view on the executive order? And also, obviously, there are people on both sides. Some people say, oh, it's needed. Some people say it's going to stifle innovation. So where do you stand, and also what is like where do we go from here with that in place?
Yeah, so when it came out, my first response was, it could have been a lot worse. So I was very worried that that the lobbyists at these bigger companies, and so I would include OpenAI and Anthropic in that group of bigger companies, that they would really try to kill a lot of the excitement in open source, for example, by just saying, oh, this is so dangerous. These like AI is going to kill us all if we don't regulate it in such a way that only us few white tech bros in Silicon Valley get to regulate all of this stuff. So I think that was a very dangerous moment. And so the UK AI Safety Summit is happening now, right? So I'm also a little bit afraid of what might come out of that, because I really don't think that we should regulate at this point, especially not from the perspective of like AI sort of taking over the world, kind of the AGI doomer scenarios. I think we have much more important issues to worry about around misinformation and things like that. So one of the things that I do think that this executive order got wrong is that they're emphasizing foundation models way too much. So they're saying, okay, these models are really dangerous if they have like this many parameters, or if they've been trained on this many H100s, then we need to regulate it somehow. And so what scares me is that the exact parameters for this are going to be determined by the Secretary of Commerce in about 270 days from now. We have no idea if this person actually knows anything about this stuff. So that's going to be very dangerous. And then the other thing is that regulating foundation models is like trying to regulate operating systems or like web browsers, right? So you can do a lot of bad stuff with an operating system, but that doesn't mean that we should try to regulate like Linux and Windows because people can do bad stuff with it, right? So similarly with foundation models, we shouldn't regulate the foundation model. We should regulate the applications that people use these foundation models in. So if you're using it in a very critical health situation, you want to regulate that market, just like you want to regulate an operating system or a web browser when they're used in that application. So I think that it really kind of misses the point here of what regulation should really be about. And so this is because of these lobbyists pushing for this safety angle. So we're not out of the woods yet.
Yeah, I think it's a fantastic point. Is that in the order they talk about, hey, if the model is this big or like bigger than this threshold, or if you use compute that is faster than X, or a data center that, so they're talking about the way in which it's constructed. But once it's out, they're like, no, nothing like you can apply to anything like that. We're not going to touch. But this, like the amount of compute you use, it stops right here. So
Yeah.
that's the
It's
yeah.
so
So
arbitrary too, right?
yeah.
So the number of flops I think makes sense, but there's all kinds of other trade-offs here too around like data versus compute, right? So can you train on maybe on more data and get a better model out? So it's such an arbitrary cutoff point that to me it just doesn't make any sense.
Yeah, yeah, and also if we know the world, the efficiency is always going to go in the right direction. In the sense that people are clever; they'll figure out how to make it faster, better, cheaper. They'll concatenate models. They'll figure it out, right? So I think
You'll
this
see a lot
question.
of like research clusters with whatever n is -1 H100s, right?
That's a good segue into my next question. And there are very prominent AI researchers on this side of the equation where they say that, hey, you know what, this regulation might not serve the purpose. And among them, Professor like Andrew Ang, Yann LeCun, who you've worked with, they're on this side. And also, maybe we'll start from there. Like you work with Yann LeCun. Like, what are some of the kind of takeaways from your time with him? And also, can you just talk about how it has shaped your view on the future of AI, like where we're going from here, given the current realities?
Yeah, so I didn't work directly with Jan, right? So I was in FAIR, and so Jan obviously is a very prominent figure within FAIR. So I think he's just incredible. He's really a visionary. I think pushing for open source against kind of what the mainstream trend is. If you look at Twitter, so I think a lot of people are actually much more like me and Jan and Andrew, where it's like, we shouldn't be doing it this way, but there's a very loud minority that dominates the debate. And I think we need people like Jan and Andrew to stand up to that. And so I think they're doing a really good job in doing that.
All right, so let's shift gears into contextual AI. For listeners who don't know, can you quickly explain what the company does?
Yeah, so we're building the next generation of language models specifically for the enterprise. So we think that language models are amazing first generation technology, but you can do so much better if you're designing them specifically for enterprise requirements. So enterprises care a lot more than consumers about things like hallucination, data privacy, cost quality trade-offs. And if you know that these are the requirements from the beginning, then I don't think you arrive at a regular language model, so big parametric beast where you try to compress all of this information into the parameters. You'll end up instead in something that is more semi-parametric, or so you have this non-parametric component, right? So we call this retrieval augmented generation in the field, and so that idea has become very popular now, which is great for me because I originally came up with that with my team at FAIR. And with this company, what we're saying is you can do much better than the old RAG, where everything is frozen, and you can build RAG 2.0, where everything is jointly optimized. So the history of deep learning has basically shown end-to-end optimized systems are always going to win. So we're building retrieval augmented language models that are retrieval augmented from the beginning. And if you do that, you get systems that hallucinate less, that have better attribution, that don't go stale, that respect data privacy, and that have much better cost quality trade-offs than a regular language model.
That's actually a fantastic point. And I want to go a little bit deeper into RAG 2.0. So again, for listeners, can you just quickly talk about RAG 1.0 and also what were the issue? What are the issues that people still use it? And then just a little bit more on how RAG 2.0, how does it function in practice? If like a machine learning engineering team, they want to use it in practice at a big company.
So RAG 1.0, the original RAG, the idea is that you have this language model, and now you want to give it some external knowledge source. So this can be Wikipedia or, just like humans. You don't have to store all the information in your brain. You can go to the library or to the web, and you can have access to a lot of additional information. So the idea of RAG when we were doing this in 2019, 2020 was to have this, would essentially be able to do open book question answering, where it would go and find the answer and then just give the answer. So a lot of companies right now are working with this paradigm because it solves a couple of the problems sort of halfway, right? So you hallucinate less if you have a RAG model. So this is like a vector database. It does some search over your own internal knowledge. you give that to the language model, and the language model generates something. So it hallucinates slightly less. It has some form of attribution. It doesn't go stale as quickly because you can get up-to-date information from the vector database. So it's kind of it's nice in the sense that it at least has a solution for these problems. It's not the perfect solution because it's all kind of cobbled together. So at Contextual, we call RAG 1.0 kind of Frankenstein's monster. You cobble together these different pieces, and then you sort of like hope that it works and it can kind of like walk around, but it doesn't really have a soul. So what you can do instead, and that's what we're trying to do, is really make sure that the parts are designed to work together. So we're kind of building like the Apple iPhone of retrieval augmented systems, where all the parts are really jointly optimized to work together from the beginning. And if you do that, so this is sort of RAG 2.0, then you get all of these nice trade-offs where you can compress a lot of the compute in the index, and you can basically have a more efficient language model that actually has stronger attribution guarantees and that actually hallucinates less.
That's amazing. And it's always nice to see how existing techniques can be made faster, better, cheaper, and also again, like the needs are evolving so fast that there's just no room to just say, oh, we got to RAG, and then we just it solved a problem, but even that comes with its own issues. Okay, so now large companies obviously. The startup land is innovating real fast. Every day, the new technique, new model, and we keep up with it. But if you're a large Fortune 500 company, you really have to kind of look at the long term, and they don't like switching products, and they have to evaluate like many vendors. So it's a longer process, and by design, because Fortune 500 company, they cannot just like blow up the business just experimenting. So apart from the things you mentioned about hallucination, data guarantees, data privacy, when they look at an LLM product from many vendors, startups, big companies, what do they really want? And also, what can a startup do to position itself against an OpenAI or a Google or a Microsoft, or name your large company?
Yeah. So what do they want? Is actually a fascinating question, because I think a lot of companies don't really know that yet. So we're basically, the Fortune 500 is reaching out to us saying like, "Hey, can you help us figure out like what we want?" Right? So some of them are very tech forward and they've already figured things out, so there are a couple of verticals like finance, for example, where people are a bit further along. So there they have already built demos, and they suffer from this phenomenon that we call demo disease at Contextual, because they have a very hard time moving beyond the demos, right? But then there are other companies where they haven't even started building demos yet, and they're really just trying to figure it out. So I think it's a very interesting point in time, because it's very clear that this is going to be a huge market. It's really going to change everything. But at the same time, there's a lot of frustration where things aren't quite ready yet. And I think that's an opportunity for companies like ours to try to do something different. But so, like you said, it's very hard to compete with basically everybody else, right? We're not the only company in the world realizing that this AI thing is going to be big one day. So I think the advantage that you have if you're in a startup is that you can benefit from the rising tide lifting all boats, right? So like Microsoft is one of the biggest proponents of RAG, which is really great for us. Right. So I think because we're a startup, we can move a lot faster. We can really be at the frontier of this stuff. And yeah, that's just, for me, like the most exciting place to work. I've been in big tech before, right? And so at the startup, everybody's aligned on the same mission, and everybody's really trying to solve this big problem together. So it's a much nicer feeling.
Right. Let's talk about the spectrum of foundation models. Meaning, on one end, we have extremely like huge, like large foundation models, and on the other end, we have a specialist model serving a very specific task or a use case, and also basically, especially the dynamic of winner take all versus diverse models serving a variety of use cases for the enterprise. So, one, how do you think this market will pan out? And also, two, like companies providing these services, how can they position themselves to address the needs and basically not go out of business?
Yeah, so I think for the enterprise, the answer is very different than for the consumer market, right? So for the consumer market, I think it's very clear that we are going to have this kind of AGI type push, right? So we want to have a generalist assistant system, kind of like a ChatGPT or a Claude or something like that, right? And it needs to be able to do everything. For enterprises, I think almost always that is not true. So for an enterprise, you have a much more narrow use case. So our bet is basically that enterprises don't want AGI at all. They want artificial specialized intelligence for their use case. Right? So rather than having this thing that knows about Shakespeare and quantum mechanics and Japanese haikus and whatever you can come up with, right? You just need the system to do this one thing, but you need it to do it really, really well. And so this artificial specialized intelligence comes with very different cost quality trade-offs, and enterprises care much more about that too, right? So I think where we're going is to this very dynamic ecosystem. It's kind of like a triangle where at the top you have these frontier models. They're amazing, they're huge, they're way too expensive for almost any serious use case. At the bottom of the pyramid, we're going to have a lot of open source models. So we're seeing this happen now. Right? There are tons and tons of open source models. There's a new one coming out every week or two. They're all amazing, but they're also leveling the playing field. So there are lots of these models. Everybody has access to them. So I think the most interesting part in that triangle is the middle part, where it's really about the cost quality trade-offs, where you can be a bit ahead of the open source models, maybe not as far as the frontier models, but you have a much better cost quality trade-off. And if you can do that through specialization for enterprise use cases, then I think you have a winning recipe.
I love that framing of artificial specialized intelligence, and I think that kind of captures what big companies look for, and also especially with this executive order, I don't think it would matter that much for the enterprise because yeah, you can build a whole bunch of single digit billion, like I don't know, 7B models to serve like a wide variety of use cases and still be within the boundaries set by the executive order. And so I think I agree that big companies, they need specialized intelligence to do like their specialized tasks and also meet the needs of an enterprise software
Exactly.
kind of offering.
But
So
there's
it's
actually an
yeah.
interesting observation around the kind of number of parameters, right? So if you think about a retrieval augmented language model, you can have a much smaller language model because a lot of the compute is in the retriever. So these are non-parametric retrieval functions. So do they count towards the parameters or not, right? So if you have to stay artificially below that number of parameters, you can just cram it all into the retriever and it'll be fine.
Yeah. And also recently I read a paper. I think you may have read it too, but uh, that talks about unbounded context, meaning how you can use this exact thing you mentioned, but take a small, artificially small model, and then the context can be unbounded and make LLMs operate like a computer, like an operating system with RAM and ROM, and um, basically the instant access memory you can store like cache, and the rest can be stored in memory. But so technically, you're using you're using a small model, you're adhering to the needs, but the quote unquote the index, the database you have can be as big as you want. So yeah, people are clever. They'll figure out a way to like meet the needs and yet get what they want.
Exactly. But so all of these ideas, like what you described, right? So this is something that sometimes irks me because I've been in the field for quite a while. But like, so everybody pretends now, especially the young kids in academia, is like that nothing happened before like 2020, 2021 when GPT-3 came out. Like there's like the pre-language model era, right? But so what you just described, that's called a memory network. There's an
Yep.
amazing paper from 2015 from
Right.
Jason Weston and crew where they do exactly this kind of stuff, right? So
Right. Right.
like we were doing all of this way before it was cool. Some people
Yeah.
should pay more attention to all of the cool
Right.
research that was happening at the time.
Right. Amazing. Okay. So, all right, let's talk about just a little bit more on the big tech companies that they've amassed a pretty big lead in AI. Mostly early on, it was mostly a function of have a lot of resources. They put a lot of people on it. They have money to spend, so they did that. And now with the executive order, it's another barrier. So, but technically, I mean, it's not unassailable, but it is a pretty big lead. So today, looking forward, where are the opportunities for startups? If you were to look like 24 months, 36 months down the line, what can they even work on going forward?
Yeah, I mean, so if OpenAI had the same thinking, then they would never have existed, right? So you have to
Yeah.
be a little bit crazy maybe when you're doing a startup and think that you can somehow do it better than these like infinite resource big corps.
Right.
But there are lots of examples of companies doing that very successfully, right? So
Hmm.
OpenAI very prominently,
Yeah.
obviously, but there are many more. So I think big companies have a lot of resources, but they also by necessity move very slowly, right? So Google was sitting on Lambda language model, so dialogue model, right? And they just didn't really want to release it, and they weren't sure what to do with it, and it was kind of scary, and there was all this like internal politics, and the lawyers didn't like it, and so you have this kind of inertia in these big organizations, and so that there's no way around that. It just it has to happen that way, and
Yeah.
so that's where the opportunity for startups comes from, right? You can just move a lot faster if you can hire brilliant people and you put them together in a small team. They can get way more done than if you put a lot of smart people in this huge organization, and they have a lot of overhead when they have to work together.
Right. Yeah. And especially as a seed stage investor, you have to believe that there's always opportunities. And yeah, I'm strongly in the camp that incumbents will do stuff. That's been true for every single startup ever. So it shouldn't stop. It hasn't stopped any startup from from doing. And funny how OpenAI is suddenly the incumbent. Like a couple of years ago, they were the young upstart
Hmm.
trying to do stuff, going
Exactly.
up against Google. So quickly, how people on that side of the argument, they say, "Oh, incumbents like OpenAI." Well, how comfortable to call
Yeah.
OpenAI the incumbent? They're not. I mean, they're not incumbents. I mean, now they're big, but at one point they're a young startup. Anyway,
Exactly.
all right.
But so if you go back in time, like 10 or 20 years, right? Like think about like BlackBerry or Nokia, right? They were like huge companies, or like
Right.
before that, like, I don't know, like Cisco. I think their stock price in 2000 was still higher than it is now. And they were
Right.
like unassailable. Like no way
Yeah.
you could get Cisco off of that top spot, right? So
Right.
that's just how the world
Yeah.
works.
Yeah. 100%. All right. You've also talked about the size of the data set versus the size of the model. Can you just talk about which one's more important and why?
Yeah, so it's always a bit of a nuanced answer, right? So, so the answer is both of them are important, and there are trade-offs between them. And I think we are still figuring out what exactly the right trade-off is. And there's a third parameter there. So it's not just about the quantity of the data; it's also about the quality of the data. So if you have higher quality, you probably need less of it to get to the same point. And then if you have enough data, then you can train a bigger and bigger model for that data. So this is kind of everybody knows about like scaling laws now, and there's this like chinchilla paper from DeepMind where they have data scaling or like chinchilla laws. I think the chinchilla estimates were proven empirically wrong by the first llama model, right, where they showed like, hey, if you train this for longer, it actually just gets better and better. And Llama 2 is just Llama 1, but then trained for longer. And the new Mistral model is just Llama 1, but trained for even longer, right? I think they trained it on like, yeah,
Right.
right? So
Right.
and what we're finding out is that if you just keep training these models for longer and longer on more and more data, they do better. And so I think we don't really know how to trade it off exactly. I'm sure some places are thinking about that very actively. I mean, we're thinking about it too.
Let's shift gears to the world of AI compute. The world is hungry for AI compute, and the world is producing a lot of AI compute offerings like chips and cloud services and infrastructure products. Will make your training faster and cheaper, will make your inference faster and cheaper. And so, if you look at all of the compute offerings in the market today, where are the gaps? Meaning, what part of the compute market is not, the offerings are not great, and there's an opportunity for those offerings to get better or faster in the future?
Yeah, interesting question. I think the obvious answer was always like there's a GPU shortage and GPUs don't have enough memory or things like that. I think right now, actually, the bottleneck that I'm seeing is network interconnect between nodes, right? So if you want to really train big models on lots of data, then yeah, network can become your bottleneck. And so if you're choosing a cloud right now, then you shouldn't just look at like, do they have the GPUs, but also like, what's the interconnect between the nodes that have these GPUs in them, if you want to train like decent sized models. So that's one of the big bottlenecks. I think it's interesting to see like with PyTorch 2.1 now, that we're moving to this world that is slightly more hardware agnostic than it used to be. I think that's a very good development. It's not good for my NVIDIA stock, but it's very good for the rest of the world. I think that there's a bit more competition there. So I think that market is going to flatten out a little bit. I think TPUs are pretty good. Trainium, Amazon is doing some interesting things there. And so AMD is getting better and better. So hopefully that will level things out a little bit. And then I think you made a good point there that inference really requires a different kind of workload, and you can customize hardware for inference much more than we have been doing. And in a way, like doing large model inference at scale is a very new problem. Right? So we were always training these big models, and it was all like slightly academic, and you could do some cool stuff with them. But now suddenly, like, this thing can go massively viral, and now you need to serve up billions and billions of users at the same time. So the inference part is actually much more expensive than the training, and so that will put a lot of pressure, I think, economic pressure on coming up with better inference chips.
Yeah, I think there's so much to do in compute, and also, I mean, it's good in a sense that if the compute keeps getting cheaper, then it's good for startups because you need compute to build your company, and if there's downward pressure on the compute cost, then you can capture that value. And
Yeah, but
hopefully, if you're starting to work, yeah.
don't you think that if you have cheaper compute, you're just going to be spending the same amount of money to get
Oh
more of
yeah,
the cheap compute?
that was my
Yeah.
literally G1's paradox is what I was about to say, is that because of just because compute's getting lower doesn't mean the world will the world will consume more of it. So net the world will consume more compute, but as a startup, the money you'll pay per unit of work, that's going to go down. Now if you choose to do more work, that's fantastic, and they will. I think if the company grows, you'll just consume more compute. So yes, it's good that efficiency is going up, but the world will still, I feel, will consume more compute.
Yeah, yeah. So there's an interesting kind of underlying question there around whether scaling laws will level off, right? So if at some point you get diminishing returns from scaling in terms of flops, then maybe there's going to be less of a demand for compute in the long run. But I think I think it's very plausible that there's almost something fundamental about like the universe, in the sense that if you spend more and more compute, then you get like richer and richer information, and out of that comes sort of intelligence, basically. Right. So if you believe in that, then maybe there's no end to the scaling law.
Yeah, yeah. All right. So, if you look at, I mean, you know, you work with customers, and I'm sure they request a bunch of stuff, and obviously you have to prioritize your roadmap at Contextual. What features are you going to build next?
So what we have on our roadmap right now, I don't want to give too much secret information away. So I think there are a couple of basic requirements that every customer has when they're using a language model, and they're the things that nobody thinks about, but they're very important. So one is like having very good latency, right? And so when you serve up big models, I don't mean like 7 billion parameter models, but like orders of magnitude bigger than that, deal with the latency there. And so I think you can do a lot of interesting things there to set yourself apart from competitors. So having good latency is kind of a core requirement for any user interacting with the language model, I think. Then the other thing is it's not just about the language itself, it's about the entire user interface. So if you actually know what you're doing with language models, then you could like quantify their uncertainty and show the user how certain the language model is when it's saying something. You can do the attribution, especially if you have a retrieval augmented language model, and say like, this is exactly where I got it from and why. Right. So these are the kind of features that we're building into our system from the beginning.
All right. I have one final question before we go to the rapid fire round, and it's on the idea of having compute clusters. And we touched upon it a little bit. And there are a couple of efforts going on at companies like Together AI or BitTensor. At least what the aim is, hey, if we have a bunch of different clusters of GPUs, geographically like different, like located elsewhere, and we want to kind of have a compute grid that can be used to train a big model. And again, the approximate analogy is like how if you have a small solar thing, you can contribute to the grid. It's like you have a little thing. If there's excess, you can contribute to the grid and make some revenue. Not apples to apples, but kinda. So what do you think about one? Is it technically, is it even feasible to connect, like, I don't know, tens of thousands of computers across the world to train a model in a reasonable way? And two, if not, what needs to be true for that to happen?
Yeah, so I think like a fully distributed global compute cluster is a pipe dream, and it sounds amazing. But I also told you earlier that the main bottleneck we see is network interconnect. Right, so that if you have like one cluster farm in Australia and another one in Canada, like that's a bit of a problem, right?
Right,
So,
right.
so there are ways to overcome that. But I think what's definitely going to happen is that the notion of kind of on-demand compute is going to commodify. So right now it's a very inefficient market, and if you know anything about economics, inefficient markets don't last. Right?
Right,
And
right.
so this market is going to become more and more efficient over time, where you basically have a framework that will allocate the compute for you based on some pricing model. It could be even like a Dutch auction kind of thing, right? Like in ads, basically, where you just go like, I have this compute job, I'm willing to spend this much on it, I have this much of a hurry, let's go. And then you'll see when you get it back and where it's going to be sent off. Like maybe it will be sent to Australia because there is a lot of like local availability there, and then with good interconnect, and then it will come back to you. So I think, yeah, a lot of people are probably thinking about how to make this market more efficient, and that's a huge opportunity, right? Because demand for compute is not going to stall anytime soon, I think, and you can just have small arbitrage already pay off in a huge way.
Amazing. All right, with that, we're at the rapid fire round. I'll ask a series of questions and would love to hear your answers in 15 seconds or less. You ready?
Yeah,
All right, question number one. What's your favorite book?
I would probably say two fiction books: Lord of the Rings or The Count of Monte Cristo. So I wasn't sure if you meant like a business book or a fiction book. So my business book would probably be Amp It Up from Frank Slootman.
Yeah, amazing. I usually keep it open mostly because it's, yeah, either both could be great. I think I'm a huge fan of books. The audience also is most
Me
of them.
too.
So more recommendations, even better. All right, next
Yeah.
question. What has been an important but overlooked AI trend in the last 12 months?
Data quality. So, like I said, there's this third parameter, right? So you have like data quantity, compute quantity, but then you have data quality, and everybody's pretending that that's not really a problem. But that's like the biggest problem.
Yeah, that's a good one. All right, next question. What type of knowledge professional is most underserved by AI right now?
Yeah, so I think that's a very curious question, because like I would almost ask you maybe if you can reverse it. So, which profession do you think is most overserved right now? I'm curious what your answer is.
Yeah, I think an example would be like there are so many tools for like marketers, right? There are like 10,000 AI like things, that tools that many people just rushed into, like, oh, we'll help you write this blog post or this text or this headline. So I feel like the marketers have too many tools to choose from. So that's on one end of the spectrum, an example. So that way, like, who is on the other end?
Gotcha. Yeah. So I don't think there's a clear answer to that yet. So I think you're right that marketers are probably the most overserved, because language models are good at sort of just generating, hallucinating basically a bunch of text, and then you can
Right,
do some stuff with it, right? So
right,
for marketing, you actually want hallucination for creative writing.
right.
But so I think almost all other professions where you don't want to have that, they are still very, very underserved. So yeah, like I said, right, that everybody can build cute demos, but to actually run this stuff in production in a way where knowledge workers can use this to actually do their job better, I think we're only starting to scratch the surface there.
Yeah, and also you make a good point. Like hallucination, to some people it's a bug, but to marketers it's a feature. Your bug is
Exactly.
my feature, so I think that just worked out really well. All right, next question. What separates good AI products from the great ones?
I think attention to detail. So, like OpenAI is amazing at that. I think Anthropic is amazing at that. So you can just see it in these places doing amazing things. Like the small things also matter a lot. And I think the other thing that people tend to forget is like ease of use, right? So what's actually setting apart what so when ChatGPT came out, what really made it special was that the user interface to language models was fixed for the first time because of instruction tuning and ROHF, right? Initially we had to like design weird prompts and things like that. It was all terrible. Like the user interface for language models was just completely broken, and then it was fixed, and language models suddenly became easy to use, and that really caused this revolution.
As a founder, what have you changed your mind on recently?
So when we started the company, we thought we would have to train our own big models from scratch. Thanks to Meta, we don't have to do that all the way anymore. So we have a good starting point. But so obviously, like everybody has access to these models, and you can do a lot with these models to make them way better than the releases that they have. That's one thing I didn't really expect, and it's going to be interesting to see if the trend is going to continue that way, where they keep doing that, or at some point it's going to be impossible to sustain.
What's your biggest AI prediction for the next 12 months?
I mean, I can toot my own horn and say that retrieval augmented language models are going to be the next big thing.
Perfect.
Yeah, that's the easy answer, right? I think the other thing that we're also seeing, which I'm also personally very excited about because I've done a lot of work in this too, is multimodality. Right? There's no reason for these systems to just be limited to text. Right? So humans don't really think in text either. Like we think in terms of the world. So if you give these systems access to the world, they will have a much better understanding of our world and how we work and what we want to get out of the world. Right? So like you can go to Wikipedia and find information about cats. And you can see that they're like small domesticated carnivorous mammals that people like to use as pets. That's the Wikipedia definition. The super boring. It doesn't really tell you what a cat is. You can also go to YouTube and watch like 1,000 cat videos, and now you really understand what a cat means to a human, right?
Right.
So this kind of richer understanding of our world, I think, is going to unlock a lot of potential for AI in the future. So not just direct use cases, but also like richer understanding of us.
Final question. What's your number one advice to founders today?
Stay uncomfortable. So if you are comfortable, you are not learning. I see a lot of people who want to stay in their comfort zones. And I think if you look at anybody who has been very successful in the history of the world, they always put themselves in lots of uncomfortable situations and then made the most out of them. So stay uncomfortable.
I think that should be a T-shirt. I think that's. I think it has potential to be a. It's a really good one. It's fantastic, and I think it captures a lot in the sense that learning and moving fast and building. These are not comfortable things, right? So if you feel too comfortable, it just means that you're not. Not moving fast enough, or you're not learning fast enough, and exactly. It's a great one. This has been such a fantastic episode. Again, thank you so much for coming onto the show and sharing your amazing insights.
Thanks for having me.
Perfect.